and welcome to my talk. We are a little bit ahead of time, so I might take some more minute or a little bit more sentences to introduce the Fraunhofer ISE, for which I'm standing here. My name is Elisabet Klimm, and I would like to talk about dust and soiling, which is one of my favorite topics right now. Here we go. I am part of the group Service Life Analysis and Material Characterization, which has the topics of performance measurements, auto performance, reliability testing, and then we also do accelerated aging testing, which is the second big pile of what we're doing, as well as analytics and the analysis itself as well. We will be sticking today to the first and also to the second and a little bit of the service life analysis, so the first, the third and the fourth topics of our group. We will be also seeing a little bit of our test sites, which is the arid and the maritime climate. And yeah, let's go to our agenda. What is actually soiling in PV? I think I should give some words to that, also to the performance loss we will be seeing, dependent on the location. And then there's the big question actually, is dust the same as dust? I have always the question, why can we not standardize soiling? And I will give you some insights, which is, on my opinion, why we cannot do that. And maybe of interest also about the soiling sensor, our soiling coverage approaches, then to see later on. In 2012, we measured, we have different kinds of outdoor locations, monitoring the performance and especially the reliability of all kinds of technology concerning solar energy. Here you can see on the top, this is PV modules and they're soiled. That means there's dust accumulation on the surface, preventing the light from reaching the solar cell. You can also see there is a clean module here. So the nice blue color, that's how the other ones also should look like. This is the efficiency, so which belongs to these modules. Quite similar, but you can see there was a major loss of efficiency, which is 80% in just a couple of months. And of course, we could clean them and you could recover the efficiency again. Oh, no, wait. On this side, you can see the IV curve. And you can basically see when it's cleaned and what happens when, how much loss you have in the current when the soiling occurs, and also when there's some hot spots happening. So that means if rain comes on the surface and the location is really covered or densely packed with soil or dirt on the surface, you have even more problems or bends. Okay, so that's so far the motivation why we wanted to look into the soiling topic and the dust topic, what is happening here in Gran Canaria. Going now to the desert location, which is our Negev test field in Israel. Also looking into now and then what is the performance loss of PV for here on the left side for 1 month and on the right side for a couple of months, actually during summer, which is for me the interesting part, in May or here in June, July, August, September. And you can see also It's not 80%, but still 7% monthly loss, which is, I think, really remarkable because per one module you have 3.8 kilowatt loss just in a couple of days. Now to our actually topic, which is desert location and why there is soiling so of interest. Of course, you have different locations. And here I want to see or tell you about two locations, just example. First is our arid Israel location. The second is, which is in fact also really dry, because Gran Canaria is located next to Morocco, so on the west coast of Africa, really dry, really windy. You can see that actually on this, on this spot here. Yes, we have sand, and we have a lot of sand there, but it does look totally different than the Negev desert sand. So this is more really light, this is really dark. Just referring, as I said before, there is some standardized test with what I'm doing, some soiling test as well. Oh, sorry for that. And that's that one. It's an Arizona standardized desk test, and it has actually totally different properties. It's reddish, it's really small, it has some fibers in it. And I'm showing you later on what it does with the surface. All right. When you ask me, okay, great, you can take the dust from the ground, you can analyze it, but I have actually dust on the surface. How should I get that? Then I'm telling you, yes, okay. We do some sampling from the ground, but we also do some sampling with dust traps. It means they are in the height where also the PV modules are located. But we also take some samples from surfaces, which are here in that way our metal samplers, which are also located in the interesting planar array of PV modules on the rack, but also in a straight position, to see there are some differences. What is also really important is you cannot always get good amounts. And that's why it's really complicated to analyze the small amounts you only get. From ground sampling, okay, you can get any amount. From open trap sampling, you get a lot of amounts, but also other traps just give you small amounts, as well as the metal samplers. This is a really important fact I need to point out here for the post-processing analysis, which we are doing with following equipment, the color meter, SEM. I'm just time-wise not explaining the X-ray, but it's basically possible and done, but also particle size analysis as well as microscopy. Just shortly, the soiling setup I developed is also some kind of characterization method. Okay, jumping into the actually dust analysis, you can see here's the luminescence and also the color parameters. And you can see there's between the dust types a factor of 2, just because the one dust is really light, the other dust is more darkish. And even in the parameter A and B, which is the red and the yellow area, even there is a large impact or large difference. What you should really need to consider. And also for the analysis of the chemical composition, yes, of course, our mineralic dust has some materials, composition, silicon and oxide, but for the maritime location, it does have also ions or nature sodium and chloride, which is not to be found in the further away locations from the ocean or from the water. Differences you can see or you can find also in the electronegativity, which might be of interest for some forces later on the structures to be really think about it. Yes, and here we can see the particle sizes. Sorry for the demo pictures. We are on the way since 2 weeks, and my origin license has only 24 hours, so it ran out. I have to update that again as soon as I'm home. If you look into the particle sizes, you can do it with laser diffraction, what we did here, only on larger amounts, just saying that. Here you can see the difference of the two locations, what we have, so negative and Gran Canaria dust. Here's the 80, and here's approximately the 45, so you have really determined peaks. If you go to another kind of particle size analysis, you can see that also here we have also a little bit more. This is Chilean dust and this is Spanish dust. What I just want to point out that you can basically see that dust types can behave different, but they can also behave similar. All right. For example, here you can see on the accumulated volume the number of the blue, which is the Spanish, and the Israeli dust. They do have kind of a similar distribution of small and larger particles. Okay. If you take images of by microscopy, you see also differences in the physical properties of dust. So there is the parameters of sorting, sphericity, and roundness. Sorting means how well they are sorted, what kind of ranges of dust particles do I have in the same package. One of our dust, the Negev Desert, is quite well sorted compared to the Canary Island dust, which you can see has large particles but also smaller particles and really fine adhering here on the large particles. That means it's extremely poor sorted and has a large range. As well as the sphericity. That means are they actually round or just long? Also here, the one dust more round, the other dust more enlarged or long. It goes with the roundness, means is the particle, has it edges, is it sharp or not? And you can see here it has still edges, it's subangular, but this is really angular and sharp. In comparison, if you ask, okay, I want to do some soiling test, I want to know what the surface is doing with the dust, or the dust is doing with the surface, everyone is right now currently doing, or everyone, a major part of the soiling community is doing that with the Arizona standard dust. Okay, this is a magnification of 100, but you can still see it's so much smaller, it has fibers, it does behave different. All right, let's move on. Now we've seen our microscopic images. And remember, I told you, there's only a possibility if you have small amounts of dust, you cannot really do a good analysis. So what you could do is actually take the dust, take whatever you have, put it in the microscope, and do some microscopic measurements to determine the particle sizes. You can do it, we did it with different magnifications. Here I have the 200. You can see here we counted actually different sizes, took an average, and plotted that. And in fact, this is an example, but it worked quite well also in comparison to our particle size measurement by laser diffraction. Here you can see we did it with 800-fold and 500-fold magnification. We have different samples, quite a lot of samples, and we have here average size of 7 micron and approximately also 7 or 6.6 micron, which goes really well with our measurement of laser diffraction. That also worked with the negative ground measurement. We could also do some measurements per microscopic and laser diffraction compared. And I'm telling you, it's a good first indication, okay, if you don't have enough sample to do that. Especially everyone is coming to me and saying, hey, I have a PV module, but I cannot scoop so much to do a proper analysis. I'm telling you, this is a simple way. It's a simplified, but it does work. In order to have some reproducible homogeneous soiling layer on a surface of solar glass, I invented a soiling test setup. This is important for also measuring in-house, indoor. We do some reproducible conditions. We have dry dusting. We can also do moisturizing before. Here you see the test setup and also some finite element modulation of the dust particle distribution within with the turbulent stream. But for now, it's just the first setup to see, okay, I have a surface, I want it to be soiled, and I want it to be measured. How should we measure that now? For that measurement or determination of the soiling coverage, we can use a small handheld, which is also in-house developed. It's quite simple, not so expensive, works on reflectance method, has a pulsed LED light, and it does filter the ambient irradiation as well, just to work properly. And what we have in the end is we have a voltage. We go on from the working principle of this, I call it soiling sensor. It's for determining the soiling coverage of a solar glass. What is here shown is the pre-measurements. Let's say we identify the measurement principles of the soiling sensor, what kind of inclination angle should we take, what is if we have a structure class, what is if we have a smooth class. The first graph shows you the inclination angle, and we choose the 85 because then we have a high sensitivity of the reflectance in order to measure all the other classes as well, the smooth and the microstructured. On the second graph, you can see what happens if we measure soil glass. Particles, homogeneous, covered on the surface of a microstructured and smooth glass. And you do see there's between the microstructured which is the green, and the smooth glass, which is the gray here at the 85, nice sensitivity for the reflectance of the soiling determination. This is important to know in order to do some measurements. Varying the dust. Here we have our Gran Canaria dust, our negative dust, and our artificial dust again. You can see the reflectance and the voltage both from the soiling sensor. And it does really match well. So I think we can just say from voltage to reflectance that we use reflectance from now on for our comparison with following, I call it our second approach for soil dust coverage, on glass. What you see here is actually the soil surfaces, and these are, let's say, anti-soiling surfaces. I don't like the word anti-soiling surfaces because they are not anti-soiling. It does still stick to the surface. Some work, but never 100%, especially if you start aging them. They are really helpful. My opinion is all my opinion. And we see why. For example, if you compare the Arizona dust, which is the standard dust, it's the reddish dust, remember, and one of our normal natural dust from Saudi Arabia, you can see it here. Well, this is different types. They're actually references. Dry dusted. No condensation, nothing on the surface. The way we did is image analysis procedure. I did some scripting. The images are sized to a correct size. They are changed to grayscale because on the grayscale you will see later it's easier for the image. Processing, the contrast had to be increased just because of the colors of the red or dark dust, and then you can plot histograms and calculate actually by definition of a threshold the coverage area, and you can see it does fit also quite well. So, for example, the A on the Arizona, you see here that the dust actually slided off. So there is some functionality of the glass, of course. And also here, the 76%. So that is the second soiling definition method I'm presenting here right now. You're asking, okay, what should I do with it? We can compare it. So whatever you have, you can work with it, either to make pictures or take a sensor. Coming now to my next slide, which does compare these two, coverage area by image processing or by soiling, sensoring. Here, plotted as percentage over the different, let's say, for now, a dry and natural dust. This is only one dust. There's much more data in behind, and only on two types of coatings, because hydrophobic, hydrophilic coatings is always the question, what should we do? If you take one glass sample, if you age that glass sample in different ways, damped, temperature, UV aging, odor reference, no aging, you can quite well compare it here with our average voltage, or the voltage in percent, it's all percent, the difference of the voltage, as well with the coverage area, what is being calculated. You can see here that actually the surface does has a influence. And you can see that also on the next slide. The next slide is also some really nice insight of our image processing results, which again has some dry soiling, as I presented how to do, and the reference, which is an unaged glass of 3 different types glass. I would like to point out here, if you check the yellow line, if you see the yellow line, that the yellow line is really behaving differently. It's the artificial soiling, or it's the artificial dust, compared to 3 different natural dust from different locations, different climatic zones, different distances to sea or oceans. Also, that is quite similar on all kinds of surfaces. So if you tell me, okay, I take that dust and I qualify my surfaces, whether it's better or not, with the standardized Arizona dust, I'm telling you maybe you should at least take one other dust, which is natural, because if you see now the red, it does behave differently. It's natural dust, it's from a maritime location. In fact, it does behave differently on the hydrophobic and hydrophilic, both hydrophilics. You can see the peak. But then I'm telling you, okay, on the other hand, the green and the blue, they kind of behave quite similar and independent of the surface. Again, it's just examples of 3. It's not the whole market there. So the take-home message actually is, I would say it does strongly depend on the dust, and sometimes it does depend on the surface as well. Coming to my conclusion, I think I'm a little bit ahead of time. We saw some soiling effects in outdoors. We had quantified. We saw the yield loss on solar systems in different areas and different locations. Especially our focus is on the arid locations, which is the desert. This is the MENA region, Middle East, North Africa, really large, really a future market for solar industry. We had the question, is dust actually the same as the dust? So we checked our analytic methods. We saw that there are differences in the physical and chemical properties, and we can also measure these. We can determine the soiling coverage by here presented 2 different methods, which are quite easy. Okay, I'm trying to make easy approaches for everyone, do at home, by reflectance or also by image processing, and they show similar methods. They're not always perfectly matching, but it's a really good qualifying method. And then we saw also from the image processes that there are large effects between the different types of dusts. Location-dependent dusts, of course, could be similar, but mostly expected. They have big influences because of the location. And again, standardized dust does not correlate with natural dust. Coming to the take-home message is, question again, is dust the same as dust? And in my opinion, I would say no. So, thank you for your attention. And I'm open for questions.
Thank you very much, Elisabet. Do we have any questions for Elisabet?
Elisabet, very nice talk. Thank you very much. Do you really believe that the natural soiling situation can be simulated in the laboratory?
Yes. Let's say that. I have also some images, not only the homogeneous, nicely covered areas, but there are images if you induce condensation first, as you have also in outdoor, and then you apply dust, and you wait and let it dry. The surfaces, I would say, my opinion, the surfaces are showing similar patterns to what we found outdoors. And then again, with image processing, you can calculate the surface. I guess so, yes. So if you also have presented or attended yesterday the talk from Karl Anders, there's also monitoring where we can take the dusted surfaces and put them on the solar cells, and then it's easier to compare actually with outdoors. Yes.
One more question here.
Yeah, thanks for the talk. Apart from the soiling itself, the abrasion due to the soiling, do you also take a look at it at the institute, or?
Yes, we do. But as I said, soiling is more like the deposition and the interaction with the ambient climate, also inducing cementation on the surface. And abrasion is more energy high impact of particles, and especially if you remember the two different types of particles, if you have the small roundish one or the larger really sharp ones. And look also at the wind speed, which we monitor, which is close to the ocean, really high, and more inland, a little bit lower. Then you definitely have different abrasion effects. And we also try to simulate that indoor, but also from cleaning. I haven't shown that. There was also another way of filtering or sieving, where you have a glass lid and a pen, which is from metal. And if you take the glass lid, there's a lot of, after the sieving, a lot of really fine particles. And if you take a brush and you can brush it, it doesn't come off. Then you have to take I take a dry wipe and I wipe it, because I don't want any other particles in my whole fractions. And then it comes off. But yes, you have to really be careful about what kind of cleaning method you're actually applying. This is a big thing for cleaning for PV modules, especially after 1 week or 2 weeks. They're soiled to a large amount of percentage, like energy performance loss. This is also large topic of research right now, everywhere, worldwide.
Thank you very much. So I did actually have a little bit of a takeaway from myself. I'm the ephemerate practitioner, really practical. My takeaway was, I think or agree from the data that it looks like that not all dirt is the same. So which means maintenance programs for these solar fields are going to be different. And then defining the maintenance program, you have a measurement method to be able to kind of guide you into what frequency that should be, and what method should be used, because obviously, as you just mentioned, the finds that are sometimes located on the surface, which are going to be unique from location to location, should be part of the consideration as well. So thank you very much for your presentation. I really appreciate it. Another round of applause for Elisabet Klimm from Fraunhofer Institute.
Hi there. Did you like what you just saw? If you did, why don't you like the video, drop us a comment below, and share the video as well, since GPD is all about sharing. And to receive more videos in future, subscribe to this channel and don't forget to click the bell icon. Ciao!